Hello everyone. Now let's proceed to the next subtopic. Measurement and assessment of light pollution. By the end of this topic, students should be able to identify the objective of light measurement, understanding why it is important in both workplace and environmental setting. Second, list the parameters measured in light measurement, such as luminance, illuminance, and luminous intensity. Third, list the instruments used, like lux meters and luminance meters, and understand their appropriate application. And finally, you should be able to describe the methods used in light measurement, including positioning, calibration, and technique for various environments. These outcomes will equip you with the knowledge to carry out effective light assessment and ensure compliance with lighting standards. Light pollution is an increasing environmental issue, especially in urban and semi-urban areas. To manage and control it effectively, we need to carry out accurate measurement and assessment of artificial lighting. This process helps us to identify problematic light sources, determine the intensity and distribution of light, and evaluate whether these conditions comply with established guidelines or standards. Understanding these aspects is essential for minimizing the impact of light pollution on human health, ecosystem, and the night sky. When conducting a light pollution assessment, there are several key objectives to consider. First, we aim to quantify the level and spread of artificial light at night. This helps us understand how much light is being emitted and how far it travels into the environment. Second, we seek to identify sources that contribute to excessive or misdirected lighting, such as poorly designed streetlights or building facade. Third, we assess the potential impacts of artificial lighting on human health, ecosystem, and visibility, especially in areas that rely on natural darkness, like observatories or wildlife habitats. And finally, light pollution data is used to support urban planning, guide better lighting design, and ensure regulatory enforcement where necessary. Each of these objectives plays a role in creating safer, healthier, and more sustainable nighttime environments. In light pollution assessment, we measure several key parameters to understand the type, intensity, and impact of artificial lighting. First, we have illuminance measured in lux. This tells us how much light falls on a surface, such as the ground or a work area. It's commonly used to assess lighting adequacy in public or working spaces. Second, there's luminance, measured in candela per square meter. This refers to the brightness as perceived by the human eye from a surface or light source. Third, we measure correlated color temperature or CCT, which tell us the color tone of the light, whether it's warm or cool. CCT can influence both ecological conditions and human health, including sleeping patterns and mood. And finally, sky glow, which represents the brightness of the night sky, is caused by light that is reflected and scattered upwards into the atmosphere. This is a major issue in urban areas and affects our view of stars and the natural night environment. Each of these parameters help us better understand the extent and effects of light pollution. To conduct light pollution assessment, several key instruments and tools are used, each serving a specific purpose. First, the luxmeter is used to measure illuminance or light intensity in lux. It helps determine how much light falls on a surface, commonly used in workplace and street lighting assessment. Second, the sky quality meter (SQM) measures the brightness of the night sky in magnitudes per square arc second. This is especially useful for assessing sky glow, a common indicator of light pollution in urban areas. Third, the digital camera with filters are used to capture the distribution of light across the horizon. This image helps visualize light spread and detect sources contributing to light trespass. And finally, the spectrometer measures the wavelength and intensity of light. It is important for analyzing the color and composition of lighting, which may affect human health and wildlife behavior depending on the spectrum. These tools together provide a comprehensive understanding of artificial lighting conditions in a given area. There are two main methods used to assess light pollution. First, we have field surveys at night. This involves using handheld device like a luxmeter or sky quality meter to take direct light measurements at specific locations. It's a practical on-the-ground method for evaluating light level in targeted areas. Second, we use remote sensing and satellite data. This method relies on nighttime satellite imagery, such as from VIRS or DMSP sensors, which used to observe and map large-scale patterns of light pollution. It's especially useful for regional or global comparison. Combining both methods provide a more accurate and comprehensive view of lighting conditions and pollution impacts. In addition to field surveys and satellite data, there are two more important methods used in light pollution assessment. First, we use GIS mapping, which combines light measurement data with geographic information. These methods allow us to visually analyze the spatial distribution and intensity of light pollution across different areas, making it easier to pinpoint problem zones. Second, we conduct comparison with standard. The data collected is compared against established guidelines such as CIE 150/2017, which provides guidance on limiting obtrusive light, MS ISO 89951, which outlines lighting requirement for workplace, and local municipal or town council lighting guidelines, which may vary by region. These comparisons help ensure compliance, guide improvement, and support informed decision making in light planning and regulation. When assessing light pollution, we use several indicators to evaluate its impact and extent. First, the upward light ratio, ULR, refers to the portion of light emitted above the horizontal plane. A high ULR indicates that a large amount of light is directed upwards, which contributes significantly to sky glow. Second, we look at light trespass levels. This is the amount of unwanted light that spills over into adjacent area or properties, such as into someone's bedroom window from a nearby street lamp. It's a common issue in poorly designed outdoor lighting. Third, the glare index, GI. It measures the discomfort or disability caused by overly bright light sources. High glare can reduce visibility, cause eye strain, and be hazardous, especially for drivers at night. These indicators help environmental health officers and urban planners identify lighting problems and recommend effective control measures. In conclusion, effective measurement and assessment of light pollution provide the critical data needed to support better urban lighting policies, safeguard human health, and preserve our natural night environment. By selecting the right tools and adhering to recognized standards, environmental health professionals can take an active role in promoting sustainable and responsible lighting practice. Your role is vital in ensuring that artificial lighting is used wisely, enhancing safety and quality of life without compromising the environment. That brings us to the end of this topic on light pollution. Thank you for your attention and participation. I hope you now have a better understanding on how light is measured, why it matters, and how it applies to environmental and occupational health. If you have any question, please feel free to ask. Thank you.